Evaluate the summation. The sum as I goes from 1 to n of negative 3 plus 2 over n I times 2n. Anytime you see the product of two expressions inside the argument of a summation, you need to distribute. So this will turn into the sum as I goes from 1 to n of negative 6 over n plus 4 over n squared I. So using the sum and difference rule and factoring out any constants, the constant rule, we can separate this sum to look like this. This will be the sum as I goes from 1 to n of negative 6 over n plus 4 over n squared times the sum as I goes from 1 to n of I. Now here, generally what happens is if I have a constant in a sum with no I will leave the constant in the sum. Because when you have a constant, all you have to do is multiply it by your upper bound. So the next step in this entire expression is to use the formulas we know for multiplying or for adding up a constant and adding up an I. And that will look something like this. Negative 6 plus 4 over n. When you look at the sum of I, as I goes from 1 to n, that is n times n plus 1 over 2. And the reason this is negative 6 I just mentioned is you multiply the constant by the upper bound. The n's will cancel when you do that. So you're just left with a negative 6. Now over here, in this other term, some simplification can happen, and this is going to be very important simplification when you start looking at finding the area under the curve of any function. So when this happens, you can generally reduce an n, or maybe two n's, but there should be some cancellation here with these n's. And if you look here, 4 over 2 also reduces. So this will leave you with negative 6 plus 2 times n plus 1. Now, why would you ever want to go through and figure out a sum like this with an n in here when you're given this expression? Well, leaving n as n allows you to say, okay, well, I want n to be 20. So instead of going through and finding this sum here for 20 and just sticking 20 in here and getting back a specific answer at the end, what you can do is leave it as n. Now you can just take this 20 and substitute it down here and for n, and you'll get some answer like, you'll get some answer like if n is 20, then the sum equals 36. And then I could come along and say, hey, well, that's great, n equals 36. What happens when n is 100? Well, you don't have to worry about finding this sum all over again. We can just take this 100 and substitute it down here. And we can say if n equals 100, that means the sum equals 196. So having the skill, figuring out what a sum is as I goes from 1 to n is very helpful. It cuts out so much work when you're trying to generalize what the sum is. So you could come along and say n is anything and be able to figure it out very quickly using your end expression. Evaluate the summation. Here we have the summation going from 1 to n of 14 plus I times I over n. So again, there's this product happening here. So the distribution of this I over n needs to happen to both terms. So this sum will equal, as I goes from 1 to n, of 14I over n plus I squared over n. Now if we go ahead and spread this out using the sum and difference rules and the constant rule, again remembering that n is a constant, you'll see that you get a sum that's something like 14 over n, the sum as I goes from 1 to n of I, plus 1 over n, the sum as I goes from 1 to n of I squared. Then the next step is to evaluate these sums using our formulas. So when you do that, that will give you 14 over n times n plus 1, all over 2, plus 1 over n times n plus 1 times 2n plus 1, all over 6. And then again, using the technique in the last example, noticing that an n in the denominator here will cancel with an n in the numerator here. Also that this 14 will reduce with this 2. That leaves you with a 7 in the top. As well as in this other term, an n in the denominator will cancel with an n in the numerator. However, 1 over 6 is already as reduced as it gets. So now we can rewrite our final answer as 7 times n plus 1 plus n plus 1 times 2n plus 1, all over 6. So here is your final summation for this sum up here. This is the final simplified version. And again, you want to keep in mind that you can reduce n's in most cases, almost all the time. And then if you can, you want to reduce the constants that are being multiplied as well.